All right, let's dive right into this explainer. Welcome, everyone. Listen, if you're a seasoned NetBackup engineer, I've got some absolutely fantastic news for you today. Transitioning to Commvault doesn't mean you're starting from scratch. You aren't learning some brand new alien technology. You're simply learning a new vocabulary for concepts you've already mastered. You already know the concepts, you know the data flows, you know the architecture. Today, we're just going to map your existing expertise directly onto the Commvault interface. Let's get right to it.
Here's our roadmap for the next 15 minutes or so. We'll start with same job, different vocabulary, then look at the architecture map, trace how a job runs, dig into deduplication and types, get into some hands-on ops, and finally wrap up with troubleshooting and retention.
Okay, Section 1. Same job, different vocabulary.
You know, at its core, every single enterprise backup product on the planet operates on the exact same underlying logic. I mean, they all have to answer these 4 universal questions, right? What do I protect? When do I run? Where does it land? And of course, how long do I keep it? Your core mission as a backup engineer, yeah, it literally hasn't changed a single bit.
So here is our one big idea for today's explainer. In the world you already know, NetBackup, you answer those 4 questions by bundling them all into a policy. Well, Commvault answers those exact same questions, but it bundles them into what it calls a plan. Different nouns? Sure, but they're answering identical questions. Basically, whenever you find yourself looking for your NetBackup policy in Commvault, what you're really looking for is a plan.
Moving on to Section 2, Architecture and Translation Map.
Look, if you can draw a NetBackup architecture on a whiteboard, you basically already know how to draw Commvault. Up at the top of the chain, we've got the CommServe. This thing is the absolute brain of the entire operation. It handles the central config, manages all the schedules, assigns the jobs, and it holds the SQL database that acts as a catalog. In your NetBackup brain, you should instantly recognize this as your master server, or primary server. It's the central intelligence of the whole shebang.
Beneath that brain, we have the media agent. And if the CommServe is the brain, the media agent is the muscle. Its whole job is to actually move the client data down to the storage library. It's doing all the heavy lifting. But crucially, the media agent also owns the deduplication database, the DDB, and the index cache. So if the CommServe was your master server, the media agent is absolutely 100% your NetBackup media server.
I want you to mentally take a screenshot of this translation table. It's a real game changer. CommServe translates to primary server. Media agent translates to media server. The client you protect, still just call the client, but the specific workload plugin running on it, that's called an iData agent. And that index cache living on the media agent, yep, that's your image catalog, the exact thing that actually lets you browse and restore your files.
Now watch out, because here's the first major day 1 trap. A Commvault storage policy is not just a NetBackup storage unit. Actually, scratch that. It's way more than that. In NetBackup, a storage unit is basically just the destination where the bytes rest, right? But in Commvault, a storage policy dictates the destination, plus the retention, plus any secondary copies. It's so much more powerful. If you go in thinking it's just a destination, you are absolutely going to misconfigure your retention.
And here is the second massive trap. This hierarchy confusion catches literally everyone. In Commvault, you're going to see the terms backup sets and subclients. Please do not mistake a backup set for a policy. A backup set is, quite literally, just an organizational folder. It doesn't do anything on its own. The subclient, though, that's where the actual magic happens. The subclient is the actual job definition where the content is selected and where the storage policy is attached. So read it like this: backup set equals the folder, and subclient equals the job.
All right. Section 3, how a job actually runs.
This flow is going to feel incredibly familiar to you. First, the schedule fires and the CommServe brain wakes up. It sees a subclient is due, so it picks a media agent from the storage policy and assigns the job. The media agent, our muscle, then calls the client. Data starts streaming out of the client to the media agent where it gets deduplicated. Only those unique blocks are actually written to the library. Finally, the index cache gets updated so you can, actually restore the data later. And the CommServe closes out the job, starting the retention clock. Brain directs muscle, muscle pulls from client. Super simple, right?
Let's pivot to Section 4, Duplication and Backup Types. Let's look at exactly why deduplication is your storage admin's absolute best friend. Imagine, for a second, you have 50 Windows VMs, they all have the exact same OS build, each with about 40 gigs of identical C drive data. If you run a full backup of all 50, that's 2,000 gigabytes of data being read from the clients. But because the media agent is hashing every single block and checking its deduplication database, the DDB, it recognizes the identical blocks across all those VMs. So out of 2,000 gigs read, it might only actually write about 60 gigs to your storage. That's wild. And it's exactly why maintaining the health of the DDB is such a critical Level 2 task. If you lose the DDB, you don't lose your backups, but you do lose the map to all those shared blocks. Now, when it comes to the types of backups generating that data, you've got your standards: fulls, incrementals, and differentials. We all know these, but I really want you to pay close attention to the synthetic full. A synthetic full is built entirely on the media agent. It just stitches together the last full and the incrementals without ever even touching the client. What does that mean for us? It means you get a brand new baseline full backup with zero load on the client and zero network traffic. Talk about a lifesaver.
Moving into Section 5, hands-on, backup and restore.
So, you need to protect a new server. It's a really clean 5-step process. First up, you add the server, which pushes the agent right from the CommServe. Second, you pick your workload type, like say SQL or VMware. Third, you assign a plan. And remember, this is your NetBackup policy moment. The plan is what carries the storage, retention, and schedule. Fourth, you edit the subclient to define exactly what paths to protect. And fifth, always run it once manually just to prove it works. Honestly, never trust a schedule you haven't proven yourself.
Restoring is just as logical. You just pick the client, click Restore, and use that index cache to browse to a specific point in time. Pro tip here, never accept yesterday as a point in time from a user. Always demand an exact timestamp. You select your files and choose your destination. But hey, be super careful here. Always double-check if you are restoring in place, which directly overwrites the original data, or out of place, which is honestly much safer because it lets an app owner verify the data first.
All right, final stretch, Section 6, Troubleshooting and Retention Rules.
When a job fails, and they will, do not panic, and whatever you do, do not immediately just hit retry. I want you to ask the ultimate L2 diagnostic question. Is it one client failing, or is it many clients failing? I promise you, that single question halves your troubleshooting workload instantly. Look, if it's just one client, your problem is client-side. Go check the client services, ping it, check the agent version. But if many clients are failing simultaneously, the issue's definitely on the path. You need to go check the media agent status, make sure the library is mounted, and verify the DDB health. Remember, doing a blind retry without a diagnosis is just a slower way to fail. Also, read the error string in the job controller. 9 times out of 10, it literally names the exact problem for you.
Let's talk about the end of the data lifecycle. So retention is set on the storage policy, right? But it's actually enforced by a background process called data aging. Data aging is just a scheduled job that sweeps through, marks expired data, and frees up those storage blocks. Now, what about moving from retention to disaster recovery? Well, in NetBackup, you used SLP duplication. In Commvault, that exact same function is called an auxiliary copy. It's just the job that copies your primary backup over to a secondary location, like the cloud for DR.
Wow, okay, we have covered a lot of ground today, so let's quickly summarize the absolute top takeaways. 1, the CommServe is the brain, the media agent is the muscle. 2, a Commvault plan is your NetBackup policy. 3, the subclient is where the actual job is defined, whereas the backup set is just a folder. 4, a storage policy is not just a destination, it dictates where data goes and how long it stays there. And 5, when troubleshooting, always ask one client or many before you even think about opening a log file.
Here's the bottom line. You didn't actually learn a new product today. You just learned new words for a product you already understand. The underlying engineering, the strategy, the deep data protection concepts, you already own those skills. You just needed the translation map. So instead of fearing the next platform migration, how quickly can you apply your mastery to absolutely conquer it? Thanks for joining me for this explainer, and I'll catch you on the next one.